questions about it. All right, so domain is, in this one, -4 to infinity. Our range was -2 to infinity. This is positive from 0 to infinity because it is above the x-axis. It is negative from -4 to 0. And I think that's as far as we got on this on Thursday. So square root functions are going to be always increasing or always decreasing. For this one, which one do we have? Increasing. We always look from left to right, so you're increasing. And so it's just going to be the entire domain, so we're just using the same thing that we used for domain. So -4 to infinity there, and it would not be decreasing at all. Brackets is going to be if the point itself is included, and parentheses is when it's not. So if your infinity is always parentheses. So for these, like particularly for the positive negative is where it gets a little bit tricky. So if you are looking at the place where the graph crosses the x-axis, you don't want to include that point because at that point the graph equals, the y-coordinate equals 0, which is neither positive nor negative. So like 0 is our x-intercept, so we use parentheses with the 0. But for the -4, like if we're thinking positive, negative, we're thinking above or below the x-axis. So -4 right here, you're all the way below the x-axis there. So you're going to include that point for that. And for square roots, unless that ends up being like your point that you hit the x-axis, you're generally going to include that endpoint whenever you're doing domain, range, those sort of things. Okay, questions? All right, here's a natural log. We have already done some natural logs here. So if we think back to what we have already done, natural logs always have that vertical asymptote, and they always have their domain restricted. So for this one, our natural log, we have a vertical asymptote right here at the y-axis. So our domain is just going to be 0 to infinity. And natural logs and e's, from our experience we've already dealt with, you pretty much always have parentheses for them. Because they have asymptotes, you never actually touch a point there. No, there's not an exception. Pretty much always parentheses for these types of graphs. The range for this is going to be negative infinity to positive infinity. That is always the case for a natural log because this graph goes up, up, up forever here, and then it's going to continue to decrease here. Okay, so positive and negative, we're thinking about above or below the x-axis. So we can see this graph right here is above the x-axis for this part, right? But you are reporting the x-coordinates where that happens, right? So the furthest to the left this graph ever goes is 0, right? That's where our vertical asymptote is. So we're above the x-axis right past 0, and then we're going to stay above the x-axis until we get to 1 right here. Parentheses for both of these because you never hit an asymptote, so you're not going to actually go to 0. Right there at 1, that's your x-intercept, so you don't include it because it's neither positive nor negative there. And then we are negative from 1 to positive infinity. A lot of times I see students want to put a negative infinity there. If you've done that, you've started thinking about y-coordinates. It is going down. The y-coordinate's going to go to negative infinity, but we're always reporting the x-axis for that. So, hold on. Yeah, that's right. So, 1 to infinity there. And then natural logs are either always increasing or always decreasing as well. So, we are going to think about just whether this is increasing or decreasing. So, linen, is this one increasing or decreasing? Start on the left. We go left to right. It's decreasing, right? So it is decreasing everywhere on its domain. So your domain is the same as where you're decreasing. So 0 to infinity. This one would never increase. Yes. Yes. Yeah. Logs and exponentials will not have that, but rational functions will. Yeah. All right, questions? So here's your example of a vertical and a horizontal asymptote. So rational functions have vertical and horizontal asymptotes. I'm going to draw them in here. Let me... Let's not use red because we have a red graph. So rational functions are going to have vertical and horizontal asymptotes. So basically for these, there's going to be a single point that you cannot have in the domain and a single point that you cannot have for the range. So when we're thinking about the domain, we're thinking about the x-axis, and we're trying to find any place where the graph does not exist for that x-axis. So if I go along this x-axis, I've got graph exists all of these places until I get to right here. Right there at 3, you have a vertical asymptote, which means that graph does not exist right there, right? If I plug in positive 3, I'm going to get 0 in the denominator. It's undefined. There's nothing. So the easiest way to write this is your inequality notation, because for your inequality notation, you can just say x does not equal 3. Or if you're using interval notation, you would go from negative infinity to 3, use a parenthesis so it's not included, and join that with 3 to infinity. This is one I do actually prefer, that inequality notation, because you can just put x does not equal 3. But you need to be familiar with both because you'll see these as multiple choice, so I might use either for that. You'll notice that that point that you cannot have is where your vertical asymptote is. It would be x equals 3 would be your vertical asymptote. Your range is going to be similar. There's going to be one value we cannot have for our range. What would it be? 2. You cannot have, the graph does not exist at 2. It doesn't ever have a y value of 2. So y cannot equal 2. Or if we want to use interval notation, it would be negative infinity to 2 and 2 to infinity. Now, I need to give you a piece of information that is not evident on this graph. Actually, no, let's do this. We can find this. Let's actually find it. To do positive and negative, I need to know where this crosses the x-axis, because I need to know where it's above and where it's below the x-axis. So to do that, I need this point where it crosses the x-axis. So I was getting ready to say, like, I probably should give that to you. And with a really complicated function, I may just tell you that the coordinates of that point are 2.70 or something. But we actually can figure it out for this problem. Okay, so at that x-intercept, what do you know about the y-coordinate? It is 0, right? Because it's on the x-axis. You don't go up any. So I could find this x-coordinate by doing this. I could plug in 0 for my y, or the f of x right here. 1 over x minus 3 plus 2. And I could solve this equation. So, for this equation, I would need to subtract 2 from both sides. So, negative 2 would equal 1 over x minus 3. And you would multiply both sides by x minus 3. So I've got negative 2 times x minus 3 would equal 1. You can distribute negative 2x plus 6 would equal 1. Subtract 6. Negative 2x is going to equal negative 5. Divide by negative 2. And you get 2.5 right there. So this is the point 2.50. Now if it is a more complicated equation, or it's something where it intersects at like 1.721 or something like that crazy, I will probably just give you the coordinates of that point. But something like this, I would expect you to be able to find it for this. So if you can't find the x-intercept, you could just plug in 0 for the y, and you can solve it there. So, so for this, I need to know where this graph is positive, and it is positive all along here. And really, all of this right here is just going to be positive, right? In fact, I think I'm actually going to answer the question where it's negative first. I think that will be easier, because you just have that one tiny little sliver. Okay, so we're going along, we're positive, 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 positive. Right here, we hit 0. After that, we're negative. Okay, so if we're doing the negative part first here. At 2.5, our graph begins to become negative. It's below the x-axis. Okay? When's it going to stop being negative? We got to think. X-axis is going to be when we hit 3, right? Because if we could hit 3, it's a vertical asymptote. So we got to think x-axis. It goes down forever, but that doesn't mean it's negative forever, right? Between 2.5 and 3, just that tiny sliver is the only part where this is actually below the x-axis. All right? Think of it, I always try to tell students, think of it with like vertical lines sectioning that off. So like if I put a vertical line right here, oh gosh, that's way too thick, and another vertical line over here, right? One of these at 2.5, the other one right there at 3. That cuts out the part where it's negative. It's just that tiny sliver right there. So I'm going to move these lines over here because they're too thick there. All right. So if that part is negative, the rest of the graph is going to be positive here. So that would be negative infinity up to 2.5 and 3 to infinity. There are times where positive and negatives may have a bracket, but you never use brackets at asymptotes or at the x-intercept. And all this has is asymptotes and x-intercepts, so you don't end up using any brackets for positive and negative. The main time you're going to end up using a bracket for positive or negative is for square roots, because they have that endpoint that's included. All right. Is this graph increasing or decreasing, or a mixture of both? Okay, it's decreasing. To me, it's like, it seems like it's a mixture, but it's actually not, because if you start over here on the left and you go along the graph, you're going down, 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 down. You keep going down forever until you hit 3, and at 3, like, you have nothing, right? And then you jump up here to the graph. So if we want to think of that like maybe sort of like at 3 you kind of increase, but it's also undefined, so we're not going to include that. And then you continue to decrease even though you're way up here more positive than you were before. So this one is always decreasing except at x equals 3 because the function's not defined at x equals 3. So it's just going to be the same as the domain there. So it's going to be x cannot equal 3 or negative infinity to 3 and 3 to infinity. And then it would never increase here. Okay, questions? All right, here's another rational. I want you to try this one on your own. I'm going to put in the try that one on your own. Make sure on the range, make sure you put a y cannot equal. I a lot of times put an x right there, which is wrong. So if you wrote it that way, make sure you put a y. All right, what questions do you guys have? You cannot, because you could never have, like you could never get 0 out of this. Because there's that horizontal asymptote there, this function is never going to give you a 0. So you have to show that 0 is not part of the range for that. It is almost negative infinity to positive infinity, but you got that horizontal asymptote in the middle that it does not cross. There is a chance, like you can cross the horizontal asymptote one time. You may see one where it happens, but this one does not, so you never actually have that out. If it did cross the horizontal asymptote, then you could have. Let's see if I've got one. It actually means that your values are going to, let me just show you like a cool graph. Look at this one. Here's one that has a horizontal asymptote that's going to cross a bunch. No. What is it? It's no. Why am I? What does it do? I know it's got sign. It's a cool graph though. Opposite. Oh, I know what it is. This one, sine x over x. So like, if you look, especially if I like, let me change it to radians. No, it's in radians degrees. Oh, way worse. Radians. Let's make our x-axis go out to like 100, and let's make this just like, let's see, -1. So if you look at this graph, it has a horizontal asymptote. Like you are approaching 0. That value is getting closer and closer to 0. But because sine goes back and forth, you cross it a bunch of times as you approach that value. So it's not a typical way that we see something being a horizontal asymptote. But
you say it has the value if it has like 0 in it with it?
Yes, so you would, like, if you were giving me the range for this, you would include 0. Because it's getting close to 0. It's approaching that 0, but it crosses it a bunch of times. So it would be included. So you're not going to see that, but I just think it's a cool graph to see there. Let me see if there's another one that, I don't know if I've got one on here. You could have one right here, so it doesn't happen on this problem, but you could have one where this middle part would go up higher right here, so it would cross the horizontal asymptote right there, where it would never actually, it would actually equal that value. So it would still have a horizontal asymptote, but it would have infinity to negative infinity for its range. So you, yes, this one does. Yeah, and we'll see it. Yeah. All right, let's see where we're at. Okay. Here's us another square root problem. So remember, square roots are going to have a closed dot on the end. They're going to have an arrow over on that other end. So if we're looking for domain here, this function exists everywhere until you get to 0, and then it is no more, right? Nothing is over here on this right-hand side. So you're thinking x-axis over here at negative infinity, you have part of your graph all the way up to 0. Do we include 0? We do, because we have a closed circle right there, and the graph does exist at that point. So we would use a bracket for that. Or the other way we can write that is we can say x is less than or equal to 0. To help you with these, if you're getting tripped up on them, whatever is underneath the square root has to be greater than or equal to 0. The square root of 0 is 0. So a lot like we did with those natural logs, where we took the inside and said it had to be greater than 0, we can always do this. Negative x has to be greater than or equal to 0. If you divide both sides by that negative 1, it doesn't do anything to the number, but when we divide by negative 1, what does it do to an inequality? Flips it. So we're going to have less than or equal to 0, so that gives you your domain for those. So whatever is under the square root must be greater than or equal to 0. All right, range, you're going to have a lowest value you can possibly have and then a highest. So lowest value you can possibly get is going to be -3. And then from there you can have values higher. So it goes up to positive infinity. Or you could say y is greater than or equal to -3. Now, I'm having trouble looking at the graph telling where this crosses. So here's another example of where I might ask you positive and negative. I may not tell you where that crosses. Also, the graph is misleading on this one. It doesn't look right. We'll see whenever we get our answer. So it looks like it crosses over here. I'll put the dot right here just because I know what the answer is going to end up being. The graph is misleading. I don't know if something was typed in wrong or because it looks kind of like it crosses at -10, but it does not cross at -10. But at this point, I know the y coordinate is 0. So if I want to find that exact point, I can plug in 0 for my y, or my f of x. So I can do 0 equals the square root of -x minus 3. And to solve that, I would add 3 to both sides. So I'll get 3 equals the square square root of negative x. I can square both sides, so 9 will equal negative x, and then I would divide by negative 1, so negative 9 would equal x. The graph is misleading. It looks like it crosses at 10 or closer to 10, but it should be negative 9 for that. I will not give you misleading graphs on your quiz. So we would have a graph here that would be positive or above the y-axis from negative infinity up until negative 9. And we would use parentheses because that negative 9 right there, that is our x-intercept. It's neither positive nor negative at that point. Our graph is going to be negative for this section of the graph, which is going to be from negative 9, where we just were, up until we get to our x-coordinate here is 0. And we do use a bracket with that because 0 is included and it is below the x-axis. Sorry, Hunter had a migraine this morning and he is at home. Oh, never mind, that wasn't that. Check it on him. All right, questions so far? Now, these are always increasing or always decreasing. So our domain is going to be the answer for one of these. Which one is it for this one? It's decreasing. To me, it seems like it's increasing. I want to start at that middle point and go out so badly. But you've got to go left to right. So from left to right, if you start on the left side and go to the right, it is decreasing. So your decreasing is just going to be your domain, negative infinity to 0. There, and it does not increase. Okay, questions? All right, so we've got another thing I want to do. So I'm going to skip this one. I want to look at this crazy one right here. Okay, now you're going to use a combination of the graph and the equation to help you answer this question, because that graph is not going to show some of your discontinuities for this. So when we have a function like this, we can tell where it has discontinuities. Anywhere it has a discontinuity, that cannot be part of its domain. So we got to look at the denominator, and in our denominator, I've got an x minus 2, x minus 3, x plus 2. All of those are going to give me places where I have discontinuities. So I'm going to have x equals positive 2, or actually, since I'm listing domain, I'm going to say x cannot equal positive 2, x cannot equal 3, and x cannot equal negative 2. Any of those numbers would give me zeros in the denominator here. If we look at the graph, okay, on this graph, I see a vertical asymptote right here at negative 2. I see a vertical asymptote right here at positive 2. I don't see a problem at 3. Why is that? What do you have at 3? You've got a hole in the graph because these two right here would cancel out. So we don't see it whenever we're looking at a Desmos graph, but there should be like an open circle right there, right at 3. It would not include 3 either. So you want to have your equation help you find the domain for that. If this is given in interval form, you would have negative infinity up to 2. Then to negative 2. We need to put them in order. Negative 2 up to positive 2. 2 to 3, and 3 to infinity. I do not prefer that notation, but sometimes it's what you see. I am going to give you a point on this, and I'm going to estimate it because I do not know exactly where it's at. I'm going to tell you that the coordinates of this are negative 0.3, negative 1.1. I'm making that up. It might be off a little bit. So if I give you something like this, I will give you the actual points, or I'll give you something that's on grid lines where you can tell. So that maximum point right there, I'm giving you those coordinates, range for this one. I do have a horizontal asymptote, and I've got something weird happening here. So I've got a horizontal asymptote. You can tell right there at the x-axis. So you can tell it looks like this is never dropping below that. It's just getting closer and closer and closer to that value there. So I know that I'm not going to have 0 here, but I also have, like, I've got this gap right here, right? So the graph here sort of has a gap. This isn't a horizontal asymptote, but if I look at this little sliver of the graph, there's nothing in between it, right? So you've got this maximum point here, then you got a gap in your graph, and then it goes up to infinity. So if you're looking at that y-axis, our range here is going to be from negative infinity up to that highest point, which I have called negative 1.1. I will not expect you to figure out what that point is on your own. I will either give it to you, or it will be something that hits at grid lines where you can tell what it is. And then 0 to infinity. So again, on this, you're thinking your x-axis or your y-axis. So down here at the bottom, it goes down forever. It stops right here at that maximum point, which my y-coordinate there is negative 1.1. Got a gap from negative 1.1 to 0 that I don't include, and then 0 up to infinity. Oh, I've messed up, though. I should have a bracket somewhere here. Where should I have a bracket? I actually include that point where I have that highest point because there is a dot there, right? It's a solid line. It's not a asymptote there, so I would do a bracket with that negative 1.1. Okay. Questions? All right, positive and negative. When I look at the graph, it's pretty easy to identify the positive and negative, like as far as just pointing them out. Right, here's my positive. All right, so I need to talk about where that graph is positive. So I'm going to start over here. It's going to be negative infinity until I get to this vertical asymptote right here that has a value of negative 2. And then I'm going to skip down. I'm negative. Oh, let's switch a different color. My graph is negative for this section. That's the part between negative 2 and positive 2. So I'm going to put negative 2, positive 2 here. Because those are vertical asymptotes, I'm using parentheses for these. And then it looks like I'm positive the rest of the time. Is that true? It is not. I'm trying to trick you. That hole right there messes you up. It's not defined. There's a hole there at the graph, so it's neither positive or negative there, and it will trick you almost every time. So because of that hole, you've got to do it this way. 2 to 3, and then 3 to infinity, because you can't include that 3 right there. So it's tricky there. Okay, question so far? Last thing on this one is where it is increasing and decreasing. This one actually does switch, right? We have some increasing and some decreasing. So if we are going from left to right, here we are increasing right here. So I'm going to go ahead and do that part. We are increasing. That was negative infinity up to, switch colors here, yellows too. Negative infinity up to -2. All right, so we were increasing there. We're going to have to skip at the horizontal asymptote. We don't want to include that. We also increase all the way up to this maximum point right here. What are the coordinates for that maximum point? Which one of those coordinates should we use? We're going to go from -2 up to -0.3. We want to use the x coordinate of that. And there is some debate over whether or not you should use a parentheses or a bracket there, because this is something that we do in calculus. My calculus teacher taught me that at a maximum point, you are neither increasing nor decreasing because you are switching. However, in general, most of the AP Calculus stuff I see, although there is some debate, some textbooks do it that way, and I think that's what she was going off of because she was an excellent calculus teacher. But for AP exam at least, they generally go with using a bracket here more often than not. And because you are from left to right, that point at -0.3 is higher than the one to the left of it, so it is still increasing. So they use a bracket. Because there is debate, and because I don't sometimes do it consistently because I can see the argument either way, I'm not going to give you anything where I count off for that. So now I will count off on basically everything else we've done before, brackets or parentheses. It does matter. But I won't give you a problem like this for increasing and decreasing where I've got this as one option and the parentheses is another option. So it'll be one or the other. Just go with the one where the numbers are correct because I will not try to trick you on that. Okay, questions? Mm-hmm. Like x-intercept, yeah. I think it has to do with how you define increasing, like mathematically, whether or not you would include it or not. I like to me, you think of like throwing a ball up in the air, like the point where it's its very highest point is not increasing or decreasing. It has stopped and it's coming back down and switching. So that makes sense to me, and that's the way that my teacher taught it to me, but I'm seeing the opposite be given as the answer more often. All right, so, but I won't try to trick you on it. Here, we're going to decrease. So that would be from that -0.3 to our +2. Again, I'm going to use the bracket because I think it's more common to see it. But if you put a parentheses, I could live with it. It'll be fine. All right, and then we look like we're decreasing all the way over here. Oh, gosh. I don't even know the answer to this. Because it's just a single point. I think we need to exclude 3. But because it's just a single point, you might not have to. I need to look into that. But I'm going to go where we exclude 3. I think that's the way it should go. So 2 to 3, and then 3 to infinity here. And I'm excluding 3 because you have a hole in the graph at that point. So we can't really see it, but right there at 3 we know we have a hole. Now, most of the problems that you're going to see are not going to be this complicated. This will be like, we'll get one of these where you'll have more of the others. Questions? I want you guys to try this one. It has no function. I think there's still a couple more points I need to give you, or may need to give you. You need these points. So this point right here is -1, 0. This point right here is +2, 0. We're going to call this one 1.5. Uh-oh. We're going to call this one 1.5, 0. We're going to call this one right here -1.5, 0. Those may or may not be right. And then this one here, this is your lowest point right here. This is your lowest point right here. This is your maximum point that you have right there. So, I think I have labeled all the points you will need to do this. I want you to try this problem on your own.
What are the top 2 points?
Those are not points but arrows. So those are just showing that it goes up. They're really bad arrows, but they're supposed to be arrows. And this does not have vertical asymptotes. So they're pretty steep. They might look like they're vertical asymptotes, but they are not. That's going to continue to go up and out a little bit forever. So. Yes, those are included. Those are closed circles. Yeah, this is one constant line. So there are no asymptotes and no holes. So that should help you on domain. May not be able to see those numbers well enough to. Here, let me write this one right here bigger, because you'll be looking at. I think I chose not to print it because I didn't want to use a whole nother sheet of paper for one problem. So that's this point right here. This one right here is 3.514. So if you can just squeeze this in wherever, if you want to use the one that we skipped, you can do that. Oh, gracious. There you go. All right, check with your neighbor, see what they've got. See if yours is the same as theirs. All right, I'm going to reveal this a little piece at a time. Okay. Domain is going to be negative infinity to infinity. Because what would give you places where you don't have a function is if you have vertical asymptotes or holes in the graph. And this does not have that, because I told you these are, although they're very steep, they kind of look like vertical asymptotes. They're going out, so they're going to go out forever, so they would go out to the ends of the infinity and negative infinity there. So, domain is just negative infinity to infinity. Range. Okay? You're asking yourself, like, do I have a highest point and a lowest point? Do you have a highest point? Not really, because it goes to infinity, right? These are going up, up, up forever. Do you have a lowest point? What is it? Negative 2.25. So it should look like this. Negative 2.25, bracket, because that is included, up to infinity. Okay, what's the next one? That's for positive. Okay, so let's highlight what we're looking at here. We're looking at anywhere we are above the x-axis. Okay, so all of those green sections right there. And we are thinking about our x-axis whenever we report this. So, although this looks really steep, it goes all the way over here to negative infinity. It is going to stop at negative 1.5. Then your negative right here, actually I'm going to do these both at the same time. So your negative from negative 1.5 to negative 1. Your positive, you're above the x-axis from negative 1 over here to 1.5. You go negative again for a little bit from negative 1.5 to 2. And then you're positive from 2 to infinity. You're only using the x-coordinates of those points because that's what we do to report positive, negative, increasing, decreasing, all of those things. Okay, questions? All right. Well, actually, let me get rid of I'm going to get rid of my highlights here. Okay, so now we're thinking about increasing or decreasing, and this one is more complicated because it switches, right? So we're going to decrease here. We switch to increasing in that next section. We decrease again, and then we increase again, right? So my yellow is my decreasing. My pink is my increasing. So again, x coordinates. So for that increasing, that's the pink sections, right? The x coordinate right here is the negative 2.514 up to the x coordinate here, which is 0.5. And then we also increase x coordinate right here, which is 3.514, up to x coordinate here. It goes to infinity because you keep on going in that direction. Brackets somewhat preferred, but you can see that I did parentheses and then had to go back and change it to brackets. So we'll have that. Then we'll be decreasing from negative infinity up to negative 2.514 and then 0.5 to 3.514. Okay, questions? All right, we're going to do some more practice with this, but we're going to wait till tomorrow to do the practice on this. I've given you a second thing. We're going to look at a sort of like an intro to a second part. Composition of functions, we're going to work on it tomorrow some as well, but we're going to do some right now for that. Okay, so we're going to be doing composition of functions. We're going to do it from a few different ways that we're going to look at it. So one way that we're going to look at composing functions is from a graph. Okay, so first I just have a graph here, and I've asked this to find several values on that graph. So whenever I see f of negative 1, it is telling me that negative 1 that they're plugging right there, it's telling me that x equals negative 1, and I need to find the y value that goes with it. All right. So if I look at negative 1 on this graph, negative 1 is right here. The point on the graph that I'm looking at is this point that I've just shown right here. What's the y coordinate for that? It would be 5. Okay. So then I'm looking at f of 6, which is going to be right here. That's where my x equals 6. The y coordinate that goes with that is 1. We okay on both of those? This is familiar. You've seen stuff like this before, I hope. What do I do for negative 2? Because at negative 2 is right here. I've got 2 places on this graph. There's a big jump in the graph. Which one do I choose? The one with the filled-in circle. That's the one that's included. So when I'm looking at f of negative 2, I'm looking right here. And I'm going to give the y coordinate that goes with that, which would be 4. Okay, so if they were both open circles, you would have to say it's undefined. There's nothing like if you don't have a closed circle somewhere, then it would be undefined. 4 asks a little bit different. It says if f of c equals -3, find the value of c. So this -3 right here, that is not our x value this time. What is it? This is our y value. So -3 is right here. We're looking for where that graph is going to have a y value of -3. That is going to be at this point right here. And this time they gave us the y value. They're asking for that c, which is in that function notation place for the x. So they're asking for the x coordinate. What is the x coordinate of this point? It is -3. So c would equal -3. Five is worded a little bit differently, but it's still asking basically the same question, all right? Find the value of x, or find the x value for which f of x equals 4. So if f of x equals 4, again, this right here is our y value. And they're asking us what that x is. That's what we're looking for. So Liam, what do you think? Okay, 0. I need to erase some stuff here. Okay, so right here, we have a y value of 4. X equals 0. I agree. But is it the only answer? Are there any other points on this graph that also have a y value of 4? We also have this point right here, which is -2. So you would actually get 2 answers for this. X equals 0 and x equals -2. Okay, questions? All right, so let's look at what this is going to look like for composition of functions. Composition of functions is when you're like plugging a function into another function. All right, so you'll see this. It's going to come from Delta Math tonight. This is going to be what you're doing. You're asked to evaluate f of g of -6. So it is written like this here. I can't remember if Delta Math ever gives you this other notation, but let me write it just in case you see. Sometimes it will be like this, f, a little open circle right here, g of x. That is the same as the notation, or I guess it's a -6. -6 right there. Could be an x, but -6. So that is the same thing if you do see that notation. I think Delta Math sticks to this mostly, but I know that this sometimes is used instead, so I want to show you that as well. So when you're evaluating a composition of functions, you want to do whatever is on the inside first. So we want to find g of -6 first. So we're going to look at our 2 functions. They are labeled f and g. We need to use g. We're going to look for where our x value is -6. That is going to happen right here on that graph. And my y coordinate of that point, if I look over here, is -2. So that means g of -6 is -2. So f of g of -6 is going to equal f of 2, because g of -6 we found was, I'm sorry, it should be -2. Yes, is -2. So you're going to plug into the inside equation first. Then you're going to take that value, the -2, plug it into the second equation, which is going to be right here, right? At F is going to have an x value of -2 here. The y coordinate there is 4. So we will get 4 for that. Okay, questions? Try that next one on your own. Okay. All right, so for this one, you're doing the inside first, which is f of 3. So f is on the inside first. We need the f function. X coordinate is 3 right here, which is going to be this point. The y coordinate that goes with that is -3. So this is going to equal g of -3. So now I go to my g graph. I'm looking where my x coordinate is -3. That is at this point right here on the graph. The y coordinate for that is also -3. So that would be my answer. Okay, does this make sense? Questions? All right. I'm going to adjust your assignment today because I don't want to, it's not that bad, but I don't want to try to cram this in right here. So let me go